Hello friends, I am Ashok and this is my first video. Now in this we will discuss about chemical structures of some compounds. Primarily we take CO2, it's carbon dioxide. It has 2 oxygens and carbon has 4 electrons in the valence shell. So carbon shares 2 electrons with oxygen and 2 electrons with another oxygen. According to VSEPR theory, this carbon has 2, 0. That means it has no lone pair and pi bonds are considered as 1 in the VSEPR theory. So it has 2, 0. That means it has sp hybridization and it has a bond angle of 180 degrees. Now let's go to another compound known as H2O, similarly known as water. Oxygen has 6 electrons in the valence shell, but it utilizes only 2 of these to bond with hydrogens, one with one hydrogen and another with another hydrogen, by leaving 2 lone pairs on the oxygen. You see, according to VCPR theory, this oxygen has 2 bond pairs and 2 lone pairs. Since it has 2 bond pairs and 2 lone pairs, it acquires a hybridization of sp3 and this angle is 104.5 degrees. Actually, any molecule with sp3 hybridization should have 109.5 degrees, but due to the presence of lone pair, it repulses the bond angle. So, the bond angle gradually decreases. Now, if you go to another compound named as SO2 or sulfur dioxide, sulfur has 6 valence electrons in its outer shell. Out of this, 4 are utilized to form a bonds with oxygen and leaving a lone pair. You see, according to VSCPR theory, it has 2 bond pair and 1 lone pair. That means this molecule have sp2 hybridization. So, any molecule with sp2 hybridization should acquire a bond angle of 120 degrees. But it not is equally to 120 degrees, but approximately to 120 degrees, since it had a lone pair on the central atom. Now let's go to SO3, sulfur trioxide. This sulfur completely utilizes the valence electrons to form bonds with 3 oxygens. If you see, according to VSCPR theory, this molecule has 3, 0. That means it has sp2 hybridization and this is exactly 120 degrees, since it doesn't have any lone pair on the central atom. Now, we will go to some complex structure like H2SO4. Of course, it can be represented by bond structures and also by ionically. Let's see the bonding structure. Sulfur with 2 OH groups, OH, OH, and 2 oxygens. You see, the sulfur completely utilizes the 6 valence electrons. We see it has 2 electrons participated in bonding with 2 OH groups and 4 valence electrons completely participating in bonding with 2 oxygens respectively. Thus, it has utilized all the valence electrons in its outer shell to form H2SO4. You see, there are 4 OH groups. If you see, there are some lone pairs on oxygen since it has only 2 bonds. Now, you see hybridization as central atom. According to SCPR theory, it has 4, 0. That is, sp3 hybridization, this bond angle should be 109.5 since it does not have any lone pair. You see, you may be confused by two OH groups and one oxygen group is on the plane. But don't think like that. One oxygen seems to be like jet plane. That means it is in the 3D direction. As we cannot represent it on a plane, we will see it as like this. Now we will go to another compound known as C2H4. You see, there are two bonds with carbon atoms between carbon atoms and two sigma bonds with hydrogen at one carbon atom and two hydrogen with sigma bonds at another carbon atom. You see, hybridization at this atom is 1, 2, 3, 3, 0. That means this carbon has sp2 hybridization and this carbon also has 3, 0. That means it also has sp2 hybridization. Now, let me tell you a shortcut. Number of OH groups in any acid which is containing phosphorus is number of oxygen atoms minus 1. You see, number of OH groups in any phosphorus containing acid is equal to number of oxygen atoms minus 1. To prove this, let us take an example of H3PO4. You see, it has 4 oxygen atoms. So, number of OH groups is equal to 4 minus 1, that is equal to 3. Let's check it. Phosphorus, it has 5 valence electrons, 4 oxygen atoms. That means 3 OH groups and 1 directly oxygen bonding with phosphorus. If you see, this phosphorus has 4, 0. That means it has a hybridization of sp3. So it has also a bond angle of 109.5 since it does not have also no lone pairs. According to this formula, number of OH groups in phosphoric acid will got 3. Okay. Thank you friends. If you like this video, please subscribe to Ashok 763 channel. Thank you.